All right, welcome back. So today we are going to be talking about what is called point slope form. And what point slope form is it allows us to take value of one coordinate point and the value of the slope of a line. And we can take that and use those values to help us convert into slope-intercept form. So again, it allows us to convert into slope-intercept form, which is of y is equal to mx plus b. So again, mathematicians aren't that creative when it comes to naming different scenarios. So we call it point slope form because we're going to be given one point, or we're going to use one point that's on a line and the slope of that line to help us convert into slope-intercept form. Now again, slope-intercept form isn't that creative either because, well, it's involving the slope of a line and the intercept of the line, hence why it's called slope-intercept form. So today we're going to be talking about point slope that allows us to convert into slope-intercept form. Here we go. Maybe. There we go. So you can graph a line if you know the slope and any point that's going to be on that line. Remember, it has to be on the same line. We're only graphing one line right now. So we need to have a point that's on that line and the slope of that line. And that's going to allow us, well, to graph. So in order for us to do that, let's say we have the example as on your guide notes. Graph the line with a slope that has 2 that contains the point 3, 1. Well, the first thing that we're going to do is we're going to plot that coordinate point. And notice how the coordinate point is plotted for you, 3, 1. I'll do that for you as well. So it's plotted 3, 1, right? X is 3 and the Y is 1, plotted. After we do that, we're going to apply the slope. The slope is 2 or 2 over 1. That means we're going to count up 2. We're going to go right 1 because our rise is positive 2. The change in y is positive 2, means we go up 2. And the run or the change in x is positive 1, meaning we go to the right 1. So we follow this pattern, right? The slope is the pattern that we're seeing of this line. And we go up 2 and right 1. And then guess what? We go up 2 and go right 1, and we're back on the line. So now we have 2 points. We can now draw the line. So all we need, again, is 2 points in order for us to graph a line. If we have 1 point and we have the slope, well, we start out with the point that we know. In this example, it was 3, 1. We apply our slope. We go up 2 and right 1. Boop, boop. Put another point. So now we have 2 points on a coordinate plane, and we can then draw a straight line through it. We can create that linear representation of our equation or of the data that we are given. Awesome. So with this in mind, please work on problems 1 through 6 on the guide notes and resume when you are ready to move on. All right, if you listen to my voice, that means that you worked on the front side of your guide notes and you are ready to move on to the back side. So here we go. We have 2 separate examples that seem to be bunched up together within your guide notes. So we're actually going to break it down and do the left-hand side first, then the right-hand side, because those are 2 different scenarios. So you can write a linear equation in slope-intercept form if you're given the slope and a point on the line. Or, this is the second scenario, if you're given any 2 points that are on that line. So let's go through what do we do when we are given the slope and a point on that line. So we have what's called point slope form. And we're going to use slope-intercept form in the later end. But for right now, on the left-hand side is what's written on your guide notes. We're given that the slope of a line is 3 and 4, 2 is on the line. So what we can do is we can write the equation in point slope form. Now, point slope form, you don't necessarily have it written down on your notes. But what point slope form is it's y, and you should be writing this down. Y minus the y value, so minus y1, is equal to m, which is your slope, times x minus x1. So again, point slope is written as y minus y1 is equal to m times the quantity x minus x1. Again, y1 and x1 are going to be the values of the coordinate point. So the y without a subscript and the x without a subscript are going to remain the same because those are going to be the x and y values, or the variables, I should say, that are going to be in slope-intercept form. So when we convert everything into it, we look at our point that we're given. We have 4, 2. So 4 is going to be the x value. That's why it's written as minus 4, because that's the x value of the coordinate point. 2 is the y value, so it's minus 2, because 2 is the y value of the coordinate point. And we want to be able to solve for y here. We want to get y isolated. The first thing we do is we are going to be solving for y. I'm sorry, going to be solving for y. They should say solving for y. There we go. So we start out as y minus 2 is equal to 3 times x minus 4. We then multiply 3 or redistribute 3 inside. We then add 2 on both sides and we get that y is equal to 3x minus 10. So that's how we use point slope form. Now, there is another way that we can use, and we can be using slope intercept form to find the missing values. So what we were given is what we were given the slope and we were given the point. So I'm going to translate what was on the left-hand side, and we're going to take some new notes about how to use it with slope intercept form. We know that m is equal to 3, and we know that we have the coordinate point. I'll change some colors here. 4, 2. We're going to use slope intercept form to help us solve this. Let me change colors. So we know that slope intercept form is y is equal to mx plus b, because that's what represents these linear functions, these linear equations. We can replace or substitute in what we know. So we know that it's y equals mx plus b. The y value is 2. The slope value is 3. The x value is 4. We do not know the b value. So we're going to be solving for that y-intercept. We can simplify. We get 2 is equal to 12 plus b. We subtract 12 on both sides. Therefore, negative 10 is equal to the b value. Now that we know our y-intercept and we know the slope, let me highlight that. We know the slope already. We now know the y-intercept. We can then change it into slope-intercept form. So it was y equals mx plus b. So now it's y is equal to 3x minus 10. And notice, it's the exact same answer as we got on the left-hand side. Y is equal to 3x minus 10. So you have two different ways if you're given the slope and you're given a coordinate point in order to write these values in slope-intercept form. You can use it during what's called the point slope form, which is y minus y1 is equal to m times x minus x1, with x1 and y1 being the coordinate values of our x and y. Or we can use slope-intercept form and we can solve for that b value, solve for that y-intercept value, because we have the slope, we have the x and the y, we need to find b. So there's two ways to do it. Whichever way feels best for you, please, by all means, use it. So that was the left-hand side of your guide notes. Now we're going to go to the example on the right-hand side, which is when you are given 2 points that are going to be on that line. We don't know the slope, but we're going to be given 2 points. So what we need to do is we need to first identify what those coordinate points are that are on the line. We have 10, 1 and 8, 5. We don't have the slope, but we have 2 points. Well, we know we can calculate the slope between those 2 points. So we're going to find the slope, and we get that our slope is equal to negative 2. Now with that, what we're going to do is we're going to substitute the slope and 1 point into point slope form. It doesn't matter which point you use. It does not matter because both of those coordinate points we're already told are on the line. So if they're both on the line, then we can use either of those coordinate points. We're going to end up with the exact same answer, the exact same equation in slope-intercept form. Because remember, point-slope allows us to convert into slope-intercept form. So we take point-slope, y minus y1 is equal to m times x minus x1. Again, y1 and x1 are the y and x values of that coordinate point. The y and the x are just chilling without a subscript. Those stay as y and stay as x. So we're going to substitute in our x and y values. They chose the coordinate point 8, 5. So again, that's right here. And then they solved to get it into slope-intercept form. Y is equal to negative 2x plus 21. Notice now, when we solve for y equals mx plus b into slope-intercept form, our slope should be the same as what we calculated. Well, we calculated slope to be negative 2. Look at that. Our slope is going to be the same in the equation. What we're trying to find here is the y-intercept. Now, we can do the same process again, but using slope-intercept form. So the first thing is still the exact same. We have two coordinate points, 10, 1, and 8, 5. We're going to find the slope, again, which is y2 minus y1 over x2 minus x1. That is a poorly drawn y sub 1. Let me do that again. There we go. When we do that, again, we get 5 minus 1, just like it is over on the left-hand side, over 8 minus 10, which is 4 over negative 2, which is negative 2, which should be the exact same slope because, well, we literally just did exactly what was on the screen to the left-hand side. So I didn't mess up there. Woo! So now we're going to take this slope and choose one coordinate point of the two to substitute into slope-intercept to then find that y-intercept. So we have y equals mx plus b. I'm going to choose, let's say, 10, 1 here because we used 8, 5 in the other. So I'm going to use 10, 1. So let's substitute in these values. The y value is 1. The slope value is negative 2. The x value is 1. And we don't know our b value. Let me highlight to show the connection here. I'm sorry, the x value is 10. Whoops, x value is 10. There we go. Now that just looks like a b. To be. To be or not to be? That is a question. There we go. That's much better. And now we're going to solve for b here. Well, we simplify down. We get 1 is equal to negative 20 plus b. Solve for b, we add 20 on both sides. Get 21 is equal to b, which is great. So now we're going to take that and we're going to apply it into slope-intercept form. Our slope was negative 2. So we add our x, and now we add 21. And again, notice it's the exact same thing as we did over on the left-hand side with the other coordinate point, right? We used 8, 5 on the left-hand side. We used 10, 1 on the right-hand side, and we still end up with the same equation. So there's a lot of different ways to go about it. It's whatever you feel most comfortable doing. You're doing great with this, by the way. Point slope is something that can be very, very helpful, but some students just like using slope-intercept form, y equals mx plus b, substituting in the x, y, and the slope, and then finding your intercept and combining it all together. That's totally fine. Some students like point slope because you know the process. You substitute in your x, y values for x1 and y1, substitute in your slope, distribute your slope, and then bring over the additional y value to get y all by itself. So it's whatever you feel most comfortable doing. But you're doing great. Great job today, folks. If you have any questions, please let me know. But please now work on problems 7 through 12 on the guided notes. Keep up the great work. If you have questions, let me know. And if not, folks, have a great day. I'll talk to you soon.